Atlas Power is trying to solve one of the greatest challenges of the clean energy transition. That's how to store intermittently produced wind and solar electricity for use at a later time when it's needed. So the best way to think about that is when the sun's shining, when the wind's blowing, the wind's blowing. But what do you do at 2 o'clock in the morning if you got to get up for some reason? You need to have a place to store that energy to discharge it at that time when it's needed. So our company makes something called a supercapacitor that we use to store this energy for grid scale energy storage.
As the world's population grows, the demand for electricity to power our cars, our factories, and our toys grows even faster. Global consumption of energy is predicted to grow by over 50% by 2050. Satisfying this demand in a sustainable manner will require not just a greater reliance on renewable energy, but also new energy storage solutions. Thankfully, innovators like Mitchell Miller, founder and CEO of Atlas Power in Abbotsford, British Columbia, are working on energy storage solutions to keep our collective futures bright.
So what's really neat and exciting about our supercapacitors is that we found a way to take the most mined and cheapest minerals on Earth and turn them into this supercapacitor. So what we do is we take basically byproducts and the enemies of the clean transition, which is thermal coal and petroleum coke. We do some magic to it with our chemical processes, turn it into a very high-grade activated carbon that we use inside of our supercapacitor cells. So what's really exciting and innovative about that is that now you have a source of the minerals you need for your batteries globally. And so the best part of that is that now we don't have to go out, build new mines, try to dig up the world in these serene environments to try to handle the challenges we need with transitioning to a clean energy future. So if you took every single energy storage technology we had today, flywheels, redox flow, pumped hydro, thermal salts or heated chambers, batteries, lithium ion, lead acid, salt water, we put everything in a big pile, it would service about 0.1% of our real-time energy demand. So think about that. That's 10 times that to get to 1% and 100 times that to get to full energy demand. And so, yeah, it's just and that's taking everything into consideration.
Our collaboration with Altus Power Generation started in 2017 and 2018. Then we start to actually the design of the supercapacitor. For example, what type of material should we use, or what type of configuration should we use in order to fit his vision for large-scale energy storage. We decided to work on thermal coal because, first of all, it's large abundance in Canada, in particular in our Alberta. And secondly, which is even a bigger challenge, is Canada is trying to phase out the thermal coal, which means people are going to lose jobs. So then we actually discussed we might be able to, solve the problem by actually redirecting thermal coal towards supercapacitor application. So if eventually the manufacturing of supercapacitor is successful, I believe it can be used for any grid storage and also can be integrated with different renewable energy, such as wind and solar.
I was very fortunate to meet a man by the name of Jian Liu years ago. And I told him what the vision was, which was, hey, can we take these low-cost minerals and make energy storage out of it? And at the time, it was kind of everybody really accepting climate change is real and this clean technology boom. And he said, yeah, I love what you're doing. Let's do it. And so we got together through a program called MyTax, which is where companies, small or large, can reach out to academia and say, hey, I've got a problem. I'd like to work with smart people on it. Let's go figure something out. And so over that time and being very well supported by MyTax throughout this journey in the University of British Columbia, we have just done that. We've reached the highest ever recorded energy density and capacitance for carbon-based supercapacitors, which is phenomenal. We've reached 35 watt hours a kilogram, 41 farads per gram. So this is a measurable improvement over all of our competitors by between 2 and 17 times. So now what that means though, for the layman's person, if you don't understand what energy density means, it means how much energy you can cram into a certain amount of material. So that means the more energy density you have, the less material you need. And so if you've got a higher energy density, you can put more energy storage on the grid faster and at lower cost.
This is great energy storage. And if we are going towards renewables, this is something we will need to make the sustainable energy sustainable and also scalable. And that's a big idea. And also, like he always wanted to keep the development in Canada, keep the growth in Canada, to bring employment, to bring this scaled up operations in Abbotsford or in BC. We know there's good stuff happening in the universities, in colleges. We know there are great stuff, great challenges are being worked on from the company side. To be able to find the perfect efficiency between the two is something extremely rewarding.
The single greatest challenge to the clean energy transition right now is that storage aspect. And so when you're looking at companies like Tesla and you're looking at, Panasonic, they're going out and they're having to try to find new resources such as nickel, cobalt, graphite, lithium. And so when you think about, hey, I have to, first of all, I have to find these minerals, then I have to bring on that production capacity, I have to mine these minerals, and you need to build all these new mines. We're talking about multi-decade processes. And that's one of the biggest challenges is that. And so what we've done is we've said, okay, coal is the most mined mineral on Earth. We mine 8.6 billion tons a year of it. So if we get that magic right of creating this very highly competitive energy storage product, we can fill a huge need on that electrical grid and allow us to transition to that grid faster.